Okay, let's look at 7,417. So here we're giving the average of $132.99 is how much men spend on Valentine's gift in 2009. Assume the standard deviation for this population is 35 and it's normally distributed. And we're looking at a random sample of 10 men who celebrate Valentine's Day. So let's look at the example and see how they're wanting us to calculate this. So first, this is like a similar problem I just worked. We want to calculate the standard error of the mean. And I'm not going to go into this part as much. I believe we were looking particularly at part E. So let's just go to part E. We want to identify the symmetrical interval that includes 95% of the sample means if the true population mean is $132.99. So it's a symmetrical interval. So symmetrical means it's even on both sides. So here's the middle, and 97.5 would only leave I think it was 95. Let's see. Yeah, 95 would only leave 0.05. So the interval would include 0.475 on this side and 0.475 on this side, which would add up to 95%. So what that means is there's a tail over here and a tail over here. So we have 0.05 left. So that would mean there would be 0.025 in this tail and 0.025 in this tail. So the first thing we need to do is we need to figure out the z-score right here up to this point. So how would we do that? Well, we would add all the numbers up to that point. So that would be, of course, our interval 0.95 plus our 0.025 tail here. So what we need to know is the z-score at the point of our interval plus the 0.025 on the bottom here. So up to that point would be 0.975. So the z-score up to 0.975, if you look at this, or if you look at what you could do is the two-tail test. Look up 0.95, the two-tail test. But you would get z equals 1.96 is your z-score. Now, since it's a two-tail test, if you wanted to just use the cheat sheet on the PowerPoint in that chapter, you could do that. What you would do is look at the little slide that has the 95% two-tail test. So how do we figure out the interval here? So we're going to do x for the upper limit is going to be your mean plus and minus the z-score times a standard error of the mean, which we already calculated in the previous step. So this video is not showing you how to do that. This is only showing you how to get this interval for the 95 percentile. So your mean that was given to you was 132.99, and we're going to do plus and minus 1.96 times 11.07. And when you do this for your upper and your lower limit, you're going to get your rounding. If you look at the example, it tells you to round to the nearest dollar. So this is kind of the number that I got, but when I round it, I'm going to get 155 and 112. Just to show you this, since it is symmetrical, if you want to know the z-score up to this point, let me show you the cheat sheet that I'm talking about. If it's a two-tail test, one place you can find it is the formula sheet for the final exam. So that's kind of where I'll go. Now this is on the PowerPoint slide for this chapter also, but just to show you. So this is for a two-tailed test, and you can see when the tails are 0.025 each, the critical z value is 1.96. So that's a way to look it up real quickly. And then again, I didn't round anything. This 11.07 was calculated and probably rounded in the previous step, but as far as the numbers here, I didn't round them until the end, and it said to round them to the nearest dollar. So let me know if you have any questions about this.